Good morning,
Yeah,
ma'am.
good morning, all. Let me just open today's data. Yeah, a very good morning. Guys, am I perfectly audible? Clearly audible? Okay, I'm asking you this because I have changed the mic. It was earlier I had to, I was using the laptop mic, now I'm using the professional mic. So in case you start getting any problems, audio related problem, do let me know. It's just the first day I'm trying it out. Okay, so that's great. Did you have time to go through yesterday's contents? The threads revision, has everyone done completely? I said the threads revision, yeah. So today, of course, we are going to revise the important statements which we made in threads. And then I'm going to take you to the second level or a higher level in threads. If you remember, from almost like strings and all, we were talking about thread safe APIs, thread unsafe APIs. So today, finally, I'll get a chance to explain what is that synchronization and what is that applying thread safety and all about it. You'll enjoy that a lot. So what are we going to do today is we'll start with, of course, a revision, basic revision. And then yesterday itself, I wanted to show you collection plus IO, and now collection and IO integrated in multi-thread application. So today, first thing we will do that. So that will be a typically hands-on session. So if you want, you can code along as always. Otherwise, you can just watch and do it in the lab session. And then first I will tell you what are the problems when you don't apply the locks or when you have the shared resources or other resource common resources shared across multiple threads. You will see something like race condition, and then we will apply the solution in form of synchronization. And then I want to show you, I have just told you that, okay, main is a non-daemon thread and garbage collector is a daemon thread. But what is really difference between the two? We will discuss. And if you ask me, is cloning related to threads? Absolutely not. But it's a small topic, so I plan to cover it today itself. Let's see what all we can cover today. Otherwise, in first 2 hours of Monday, we'll do that. And definitely we are going to start with advanced Java Monday onwards. Monday, maybe second half onwards. So start. Please keep, before I start the revision, 2-3 documents open. So one document is thread state transitions, that diagram which I have given, which has does not exist, new, runnable, as in ready to run, running, dead, all those things. And other thing is keep the threads API also open. And the third important summary diagram is blocking triggers versus blocking versus non-blocking triggers. So keep all of that open. You will be able to revise with me quickly. So which is the first state in the thread state transition? Does not exist. So whether it is a system thread or whether it is a user-defined thread. No, no. Before that, before new, there is a does not exist in Srinivas. So does not exist to new. So which are the different techniques you have seen yesterday, which will create a new thread in Java API? Anyone wants to tell me? What are the two different techniques we have discussed to create a new thread? Yes. Give me all of you. I mean, majority should answer because it's a basic question. It's a extends thread and or the implements runnable scenario. And I hope you have solved yesterday's assignment using both.
Hello, ma'am.
I got disconnected. I think I had some network glitch or something. Okay, so I was asking you, between runnable and a thread, which is the super type? Runnable interface is the super type. So runnable interface, as you all know, it is a functional interface. So which is that functional method, or which is that single abstract method which you have to implement or override in either cases? Give me the full signature, full method declaration, public void run. So is there any relationship between runnable interface and a thread class? Is there any relationship, or there is no relationship? Of course, there is a relationship. Which relationship? Don't just say yes. Which one is a relationship? Everyone knows that. Thread is a runnable. Thread implements runnable. So it is a implementation class of runnable. So now your new thread class instance has been created. So let me ask you immediately. Everyone knows the constructors. So can you tell me which are the constructors which you'll use in the extends thread case? Suppose I want to create a named thread, which is the thread class constructor we used in the extends thread scenario. Yes, it is nothing but the thread and the name of the thread class constructor. So here you supply the name of the thread. If you don't supply the name of the thread, will the thread not be created? Of course, it will be created. But who will supply the name? Java will supply the name. So if you are happy with that, you can create a you can use a default constructor, or otherwise this. Now, if you have implements runnable scenario, you have to pass the runnable task. So can anyone tell me which is the constructor we had used in the implements runnable scenario? Which is the thread class constructor? What are the arguments, please? You have to supply. Very good, Nidhi. Very good, Srinivas. So here you have to supply the runnable task, or you can say runnable target, runnable instance, anything, and the name of the thread. Okay. So what is it you are supplying? What is it you are telling the JVM or Java here? If you use this, the my thread or your child class is a thread. So that child class's run method will be called. But here, when you use the implements approach, for example, public class my task implements runnable. My task is not a thread. My task is simply representing a runnable task. So whenever this thread gets a chance to execute, whenever it gets a CPU time, which classes, which method your JVM is going to call? This instance of that implementation classes, or that runnable instance of that my tasks run method will be called, and that is the meaning of this constructor. Okay, so these are the two approaches. Now, so your thread is already created. It is in the state new. So has it started execution yet, or not yet? Answer is no. So I asked you yesterday, which of the following options are correct? First option, thread class instance is created and sitting in the Java heap, option 1. And option 2 is a separate flow of control has been created and started. Which option? Only option 1. Everyone understands. And guys, if you have read my PPTs slides in that PDF format, I have mentioned all of that properly. So now which is the next transition? New to ready to run. Actually, you can say new to runnable also, but it is better to separate it out. New to ready. So here, is it a pool? 100%. When I say pool, what will it have the single thread, or can it have multiple threads in the pool? Multiple threads. Which is the internal data structure typically used to create the ready pool? Data structure, please. Priority queue. Very right. So here pool is equivalent to, or pool means sharing of resources, or it means collection of equivalent resources. So when you say ready to run, what does it imply? The threads in this state, are they blocked on any condition? Are they blocked on sleep? Are they blocked on input? Are they blocked for join or something? Absolutely not. They are not blocked on any condition. But what is it they are waiting for? They are simply waiting for, patiently waiting for CPU time. Everyone understands that. So they are waiting for the CPU attention, CPU time, exactly. So how to trigger this transition? Which is the method of the thread class to do new to ready to run transition? Start method. So it is all the thread class method. It's a it's a non-static method, public void start. Got this? So now your threads are waiting in the ready pool. So these transitions does not exist to new to ready. You could manage it easily. I mean, they are under the programmer's control. But once your threads are placed in the ready pool, who is going to manage ready to running transition? Don't be under the wrong impression at all. You are not managing it. Neither is your JVM. JVM simply gives those Java threads to the underlying operating system. And finally, it is all managed by the contract between, I mean, it is ultimately managed by the operating system scheduler. So it is all done between JVM and the native operating system. Java programmer cannot, I mean, Java API cannot control it. And whenever your thread is placed in the running mode, running state, that is the time it will start executing. It will get a chance to execute the run method. And that is why you have to implement, or you can say override, the run method to supply your own business logic, your own execution logic. Everyone is clear? So this ready to running is the swapping in, and running to ready is swapping out. So this is nothing but context switching. Who is managing this context switching? Underlying operating systems. So now I have already written. So what are the different triggers for running for a thread which is running? Go back to ready state. So if you are using the round robin time slice based, scheduler, the moment the current thread's time slice is over, the thread will go back to ready state, running to ready. If you are using preemptive multitasking, I mean your operating system is using preemption, the moment higher priority thread becomes ready, lower priority will be preempted, swapped out, higher priority will be swapped in. But is there any Java API, even though unreliable, is there any Java API where you can request this transition? Yes, and that is your yield. So yield is what? Static method or non-static method? It's a static method. And when you say thread.yield, your running thread is requesting the JVM and the underlying operating system, swap me out, so that some other same priority thread or a lesser priority thread may get a chance to run. But is it going to be 100% followed by the underlying operating system? No guarantee. In short, whenever we are writing any multi-thread application, we will not use the yielding, or we will not rely on yielding to, yeah, it is a request, exactly. So we will not use it, but as an exam objective, you should know. So now what is this combo? What is this combination of ready and running called? The thread state is called as runnable. Next transition. When you say, when will a running thread become dead? The whole idea is to execute a business logic. So the moment run method is over, running thread becomes dead. And tell me, can you restart a dead thread? You cannot. So the rephrase question, all these are popular questions. So I'm just putting it in a proper readme kind of a thing. What are the triggers for illegal thread state exception? So there are two triggers. If your thread is dead, and by mistake, if you call a start method, guys, you can only call start method on a newly created thread. So if you call a start on dead, you saw yesterday, all this we have seen. So I hope today you have a better feel. So you'll get an illegal thread state exception, or even when the thread is already runnable, means it is already started, and once again you call a start method, 100% your invoker thread, wherever you are calling start, you will get a illegal thread state exception. Understanding each and every word now? I hope you have slept over it. When I say sleep over it, you know what I mean is you have gone over it. You have looked at the code, you have solved this, you have read the readmes, and people are getting clarity. Okay, next one. The most important, the one which really requires understanding is the transition from running to blocked. Because if you have got a decent, when I say decent, medium-sized business logic, which is a real practical scenario, it is impossible. I would say impossible. Impossible is a strong word. It is unlikely that your thread gets a chance. I mean, it starts executing the run method and finishes the entire execution without getting blocked. So the running to blocked is one of the major transition. So everyone knows why we are having multi-threading or multitasking, to ensure that if a one particular thread gets blocked, should it affect the execution of other runnable threads? Of course not. So that, do we want to keep our CPU, our resources idle anytime? Absolutely not. We want to keep your CPU always busy. So that is when, so anytime a running thread comes across any blocking condition, which could be sleep, which could be join, which could be waiting for input, which could be wait, whatever. So immediately scheduler will release the CPU and the thread will enter the blocked state. Are we still good? Everyone can visualize. That's why I said keep that thread state transition diagram completely in front of you for 100% clarity. So now easiest triggers. So I'm just now discussing or revising your blocking triggers with some code or some example. So first method is sleep. And I've already written this. Public void sleep. The unit is long millisecond. If you open the thread class, there is an overloaded sleep method which has long millisecond and long nanosecond. But guys, unless and until you are using RTOS is real-time operating systems like SpectraWorks, VxWorks and all that, you cannot achieve the nanosecond precision. So for all practical purposes, we use sleep in milliseconds. Okay, so the moment you see in the throws class, interrupted exception. Yesterday I was explaining this throws keyword to somebody. I don't remember the name. So tell me, listen to the question, please. When you call thread.sleep, is it that every time the thread is going to get interrupted exception? Maybe or every time? Possibility or every time? Answer is it is a possibility. Okay. So when will a sleeping thread get the interrupted exception? When will a sleeping thread get the interrupted exception? Yes, some other thread, not main, don't say Kunal main, any other thread sending the interrupt signal to the sleeping thread will get a interrupted exception. So guys, I'm trying to, prepare you. So anytime in the API, in the methods, if you see any method having throws interrupted exception, what is the understanding you should have? You should immediately understand that the corresponding method is a blocking method. Means it will release the CPU and enter the block state. And the one of the unblocking trigger can definitely be the interrupt. So, be smart, look at the simple things and keep the understanding clear. So now I have a question. So here I've written as a simple example. We have done all of it yesterday. So I hope to get the correct answers. Anyway, don't hesitate. Give me some answer. I'll correct you if it is wrong. Imagine you have got a thread T1. T1 has its run method. And in the T1's run method, I have written suppose thread.sleep 1000 in a proper try catch block. So tell me, if there is no interrupt from any other state, any other thread, any other concurrent parallel thread, what will happen after 1 second? Is it going to get an interrupted exception? No, it will just be unblocked. So here After 1 second, thread is unblocked. When you say unblocked, sorry, will it go directly to running state? Never. So it enters the ready pool, and whenever it gets a chance, then it will resume. You understand, resume. It is not going to abort that try catch block. It will resume, or you can say continue running. 100% clear? Zero confusion? Okay, great. Now, I have got another scenario, or so treat them separately. So you have got T2 now. Okay, in T2's run method, here now see the situation. Okay, I'll copy this. So that whenever you are revising it, you should not have a confusion. Okay, so now let us say there are two threads, T1 and T2. T1 is nicely sleeping in its run method for a 1 second. But now there is a parallel thread T2, and in T2, here you are saying T1 dot interrupt. So who is sending the interrupt signal to whom? You have the answer already. T2 is sending the interrupt signal to T1. So after sending the interrupt signal, does anything happen to T2? As in, does it get blocked? No. It says runnable. When I say runnable, it could be running or it could be in the ready pool. So be clear. But the question is, what will happen to T1? T1 was nicely sleeping for a 1 second, but before its sleep got over, it got an interrupt. So tell me, will it say blocked or will it be unblocked? 100% unblocked. But this time, exception or no exception, sleep interrupted exception goes to the ready pool, and whenever it comes to running, whenever it gets a chance to run, will it simply resume the running, or will it go to the exception handling block, catch block? Of course, the corresponding try block will be aborted and it will enter the catch block. So tell me, is the first sleep method and its unblocking trigger? So let me ask you, what are the two unblocking triggers for the sleep API, for the sleep method? Answer is in front of you. I want two unblocking triggers. Two unblocking triggers means when it will be over, like. Which are the two unblocking triggers for a sleeping thread? Yes. Don't say restart. What kind of answer? Restart, I don't understand. Interrupt and or sleep over. You can say timeout or something. Sleep over, sleep duration over, which is timeout, or you can say interrupt. Now, then we had looked at join. So tell me, join is a non-static method of a thread class. Is it a blocking API or is it a non-blocking API? It's a blocking API. So what is the simple description? The join method causes blocking of the invoker thread till the specified thread becomes dead, specified thread becomes over. Okay, so take a look at some example. You got T1's run method. Try, you know, join is having that again, join again has that throws interrupted exception. So suppose I have said here some business logic dots are, then I'm calling T2.join 1000. So here the moment the T1 calls T2.join 1000, is it going to continue to run or will it be blocked? Running or blocked? Of course it will be blocked. Okay, so basic understanding is T1 waits for T2 to complete the execution. Just let me tell you my inputs. After that, I have written a SOP, continued, and then I have got a catch-all block, and then the run method over or something else. Now I'm giving you different scenarios. Okay, so here, can you imagine? You can draw on a piece of paper T1 run method, just one line T2.join, or you have the whole code in here. Now I'm giving you different conditions. So this is the line you have to catch. I mean, you have to like focus on. Now I'm bringing in T2, and suppose T2 gets over in 500 millisecond itself. T2 is dead. Its business logic is over. So in that case, what will happen? When I say what will happen to T1? Will T1 continue to stay blocked because of this 1 second, or will it be immediately unblocked? You understanding? I said will it be unblocked or will it stay blocked? Of course, it will be unblocked. See, any trigger, whether it is a thread over or interrupt or later timeout. So of course, T1 is being unblocked. Means what? It goes to the ready pool, and whenever it gets a chance to running, tell me what it will do. When it comes to running, is it going to continue the execution or is it going to enter the catch-all block? Answer is continued. Okay. So this is the quick way, guys, to keep the code, concept and everything together and understand. So this was one situation over. Now I'm saying, so ignore this now. Now I'm giving you OR. So, so let us say T2 is not dead. Okay. So T1 is nicely waiting for T2 to finish execution and bringing in the third thread, T3. And after 700 milliseconds, I'm saying in the T3's run method, T1 dot interrupt. Tell me what will happen. So when I say what will happen, I mean what will happen to T1. Will it stay blocked or will it be unblocked? Who is sending the interrupt to whom? T3 is sending the interrupt to T1. Yes, wrong answer, Rajiv. After getting the interrupt signal, join can be unblocked. So 100%, yesterday I showed you also. So here, this will be T1 will be unblocked. When I say unblocked, where it will go? To ready pool. So here, after it gets a chance to running, now tell me, is it going to continue the execution or is it going to enter the catch-all block? Catch-all block. And which exception, of course, it will get? Which exception we all know? Join method gets which exception upon interrupted? Interrupted exception. So it will enter a catch-all block. And which is the exception you expect to see? Interrupted exception. Okay. So this is your second scenario. I hope you are able to put it. If you are not getting it, write a two-liner code, multi-threaded application I've shown you yesterday, or copy one of mine and play with it. Now the last scenario. Okay. So what is the last scenario? T2. So this part is the same. Okay. This is the given. Guys, prepare yourself for such questions. Anyway, so T2 is still runnable, not dead. And you are not getting any interrupts from T2 or anywhere. So no interrupts from any thread and T2 doesn't get over. So now tell me what will happen after 1 second. Will T1 continue to get blocked or will it be unblocked? Of course, unblocked on a timeout. Everyone understands? So the same story repeats. It goes to the ready pool. And whenever it gets a chance to this thing running, will it go into the catch-all block or will it simply continue? Catch-all or continue? Of course, continue. It's just a timeout over. There's no exception. So this is the same answer as this. So what is going to happen after 1 second is this much. Are we all good? Are we all understanding it clearly based on yesterday's discussion and all of that? So that is what is your second blocking trigger. So now consider the third one. The third one is blocked on input. Guys, before threads for last 2 days, we were in IO. So tell me, when you use java.io, is it full of blocking API or non-blocking API? B or UL? Blocking. Means what? Anytime you perform any read operation or write operation, till that read and write operation is over, can the invoker thread continue or will it stay blocked? Answer is stay blocked. So that is my third trigger, blocked on input. Generally, writing part is like finishes faster. So I'm not taking, but you can always have blocked on output also. So I'm giving you a question. Suppose you have a T1 thread. In its run method, suppose you have passed a scanner, which is not a good idea actually. But I just want to ask you. Let me ask you. On the first day we met, I told you, scanner has the blocking APIs. So imagine you have given a prompt, enter a number. and in the threads run method, and you have said in the run method sc.nextEnd. So till the time user gives you some input, will your T1 be blocked or will it be not? Will it continue? Of course, it is going to be blocked. You have seen all these days main thread getting blocked. Now it will be T1 which will get blocked. Okay, so that one. Another example. Everyone knows system.in. What is system.in? The standard input. The data type of standard input or system.in is input stream, and input stream has a read method. So tell me, when you say system.in as an input stream, is it a binary? I'm talking in the IO now. Is it a binary input stream or is it a character input stream? B or C? Input stream is what? B or C, binary or character? Binary. So in short, this method is going to wait for 1 byte, at least 1 byte coming from the user. So I'll give you a usage. You just want to keep the application running till user presses enter or on a keystroke. So you can say press enter to continue or press enter to exit or whatever. And then when you say system.in.read, will the thread continue or will the thread the thread be blocked on input? Of course, causes the invoker thread to block on the input. Understood me perfectly, completely? So tell me, in the T1's run method, if I have not supplied any input, can you tell me what is the state of T1 currently? Yeah, I am not accepting this half answer. Blocked on which trigger, which condition? Is it blocked on sleep? Is it blocked on join or is it blocked on input? Answer is right in front of you. So you can, you know, clearer you are, more precise answers you give to the interviewer doesn't have to ask you much further, because there's a clear-cut communication between you and the evaluator. Okay, so T1 is, imagine, out of competition, blocked on input. Okay, so that is a given. Now I'm saying you have a parallel thread T2 and T2. Okay, in the T2's run method, I have called T1.interrupt. So tell me, already there is an answer. Who is sending the interrupt signal to whom? T2 is sending it to T1. Everyone good so far? So now in that case, T2 continues to stay runnable. That is fine. But earlier, you remember we used to say T1 gets unblocked. So the question is, answer is already there. Is the interrupt signal unblocking trigger for the threads which are blocked on input? It's a Boolean question, yes or no. Capital no, absolutely no. You can try it out. In the lab session, you can try out such things. So 100 interrupts even if you send, 100 is just a number. The thread which is blocked on input will stay blocked. Okay, so interrupt is not an unblocking trigger for the threads which are blocked on input. So anyone can tell me, anyone wants to tell me, which is the only unblocking trigger? I've written all of this in my that one slide, blocking versus unblocking trigger. So what is the unblocking trigger for the threads which are blocked on input? Yes, please. What is the only unblocking trigger for this? Is the sleep. Come on, sleep is a blocking trigger. The input, yes. So the only unblocking, guys, wake up, don't sleep now, literally. So here, I want the thread to go from block to ready. So the only trigger is data available. Whatever you are waiting for, data being available. Okay, so only that is the unblocking trigger, because your input or any read methods and all do not have any interrupted exception. If you want to use interruptible IO, will you use java.io API, or is there there's a separate package called as java.nio, non-blocking IO. So if you use java.nio classes, then they are interruptible. But you don't have them in the syllabus actually. So Java.io, anytime you say scanner.nextInt or any such read methods will continue to stay blocked. Clear or not clear? 100% clear? And see, each and every scenario I'll not take. This scenario I'll not taken, but you can always try this out. So now, when the blocking condition is removed, in general, the thread goes from blocked to ready, competes with other threads in the ready pool. And then whenever a highest priority thread is picked up by the operating system, JVM and OS combination, and that gets a chance. Now the next question. What is mandatory in either of the scenarios? Whether you say extends thread or implements, tell me, what is compulsory in either of the cases? What is compulsory for the programmer? Must implement. See the verbs I'm using. If it is extends, override. Because you have a base class version. Must override. Or if you are saying implements interface, implement the run method. Okay, so that is common. So here, what will happen? These are the favorite questions. We already discussed them yesterday. What will happen if you have an extends thread scenario and you don't override the run method? Will you get any compile time error or a runtime error? Absolutely not. But what will happen? Will your thread be a useful thread performing some business logic, or will it be a do nothing, no operation, no operation kind of a thread? It will be a useless thread. And why? Because it is simply inheriting the blank implementation from the superclass, which doesn't do anything. So that is why you will never do this. And on the other hand, if you say implements runnable and don't implement run method, of course, compiler detects it and throws you out. Clear about what will happen? All these are, guys, whenever you are preparing for exams, interview rounds, definitely go through this. So seriously speaking, you know, after giving you so many readmes, separate interview questions are seriously not required, because every now and then I keep talking about that, what will happen and all that. So do prepare well at the correct time. Next one. Another interesting question. What will happen? Somebody had asked me yesterday, which was a really good question. Instead of calling start, by mistake, if you directly call a run method, will you get compile time error or runtime error, guys? You know the answer. Will you get, instead of calling t1.start, I directly call t1.run, zero error. But it is completely, it's a programming logical error. Why? Because run is any ordinary method. Okay. So when you call t1, so imagine you have a main thread. Main thread may you have created a t1, thread t1 equal to new thread something, and you said t1.run. So which thread will be executing the business logic you have written in the run method? Main thread or t1? Main thread will be executing. So what is it you are having? Are you really enjoying the multi-threaded scenario, or is it a single-threaded scenario? Single-threaded scenario. In short, sequential execution or parallel execution? Answer is sequential execution. So this is what was a detailed revision of all the things we covered yesterday. Are there any specific questions after this? Does anyone want to ask me anything? If you tried something and did not work or whatever like. Okay, keep writing your questions now. Now in between, I will not allow you to interrupt, because just keep the questions aside. If you have right now, ask me. It's a good time to ask the questions. But later sometimes, you know, a question pops up in your mind. Just keep it aside and save it in the sense, and before the break or after the break, you can ask me. So now let us enter first hands-on exercise of today. Nobody is going to ask you to write a multi-threaded application to print something like even numbers, prime numbers, and composite. You will be given a business scenario. And that business scenario, you would like to do it in a multi-threaded manner. So collection and IO, we have already integrated. Your project is all about that. Madan, I told you now. We just I am not looking at your question because it, you know, it breaks my flow. So here, we already have a collection and IO, but all these days we were working in a single threaded scenario. So now we want to apply threads and we want to see whether you can see the concurrency. So read this. I'll wait here for a minute. I'll just give you just a second. Wait a second. Yeah. What I'll do is, as usual, give me a second. I'll share this sequence with you. I'm sending you the sequence. So, you can read this question anytime you want. So I've sent you a sequence.txt. Download it immediately. After 10 minutes, if you realize that I have to download something, it might be gone from the chat. I mean, overwritten. And one more thing I'm going to show you. I'm going to give you rather. Yeah. So I'll send you one more thing. A diagrammatic representation of this assignment. The name is collection IO and threads. So right now, don't open the diagram. Right now, just open the sequence and here. So we have the statement. I'll send you some ready code also. I've sent you that student code earlier, but anyway, I'll send it again later. So is the question clear? Read the question, please, and tell me. That is what we are going to solve in next whatever time. You read it. And tell me once you have read the question. Waiting for your response. Read this? Okay. So now tell me, are we going to write a single thread application or multi-thread application? Answer is right in front of you, multi-threaded. How many threads are we going to have in our system? Don't count the garbage collector. 2. Count again. 3 is a correct answer. Main is already there. And from main, we are going to create 2 different threads. One to do the, see, this is a collection. Collection part is sorting. I mean, the list and handling the maps and all that thing. And then the IO part is writing this. What does it have set in? Yeah. So 2 text files. So I will take the student collection. We'll sort it as per the criteria. One is GPA, one is DOB, something. And how many files are we going to create? 1 or 2? 2 files. So can you not detect the concurrency? Can I not do this activity in a parallel manner? I can. Let one thread take students' data, sort it as per GPA, and store it in one of the file. Let's say student GPA.txt, and let another thread take the same student's data, sort it as per DOB, and save it elsewhere. Is the requirement clear? Is the question clear? And like I said, I always like to draw the diagram to give a better feel. So open this collection IO threads. So the problem statement is already there. So I've just put it in a, design kind of a thing so that everyone will understand. So this is, I have given inputs. Later, I'll give you some requirement to solve on your own. So how do you approach the problem? This is a little advanced level problem because it has got collections, it has got IO plus threads. Okay, so here you first draw the threads which are going to be required for the application, and then you jot down, then you identify the to-do list, the job list each and every thread has to do. So you can see I've got main thread. I have got another 2 threads. One is DOB based sorter and one is, here I've said subject based. Okay, subject DOB, I mean GPA, doesn't matter. It's just a criteria. So we'll solve it as per the problem statement. So can you at least identify these 3 threads? Which will be parent and which will be children thread? Everyone knows main is going to be a parent thread and the sorter threads will be child threads. Are we going to use runnable approach or extends thread approach? Implements runnable throughout. So these will be the tasks. One will be the DOB sorter task, one will be the subject sorter task, and we'll do it accordingly. So now Start identifying the steps. We are going to write it. That's why I shared this diagram with you. So main thread, what is it going to do? See, I can write it as a full-fledged end-to-end, but takes the whole day. So we will again work with the sample data. I'll send you all that. So main thread will get the sample data from the collection utils, and we had worked for last few days in list. So let us work in map. So in a hash map, main thread has to create the children threads and the same data. Are you understanding me? The same hash map will be sent to both the threads. Now tell me, where will be user interface? Will it be in main or sorter child threads? Scanner, where will be scanner? In the main thread. So main thread will talk to user and will ask which text file names you want. So here we will be creating the thread. The main will be creating the thread. And what is it your main will pass to these children threads? If you have solved your yesterday's assignment, what were you passing? The range, the beginning, start and end. Here you will be passing the shared data hash map and the name of the file where the data has to be written. Is the data exchange clear? The main thread will be passing the shared data, that is hash map of students, same students I want to operate on, and the name of the file. Is this part clear? You tell me yes or no. Frankly, because we're going to write it, we're going to put it to Java code. Once your design is done perfectly, implementation, trust me, becomes easy. Okay, so now see, currently it is a classroom sample like for 5, 6, 7 students. But in actual reality, there can be 5,000 students. So we don't know, as in main thread doesn't know how long it is going to take for the individual thread to finish the application. So should we go for the orphan scenario or should you ensure no orphans? Always. Of course, no orphans. So main thread is going to wait for children threads to finish execution, and then finally main will be over. So spend half a minute and check whether the to-do list or the job list of the main clear or not. You should be able to visualize that this is what 1, 2, 3, 4 things I'm going to do in the main thread, as in the main method. Are we clear? Okay. Now look at one of these threads. I'm just going to explain one of them. The other one is almost similar. So suppose I say I want to sort these student details as per the date of birth. Criteria can be anything. So suppose say date of birth. So now here, let me ask you, in this will be a task. So if I talk in code, public class, DOB sorter, implements runnable. So think and answer. Will you define any data members here? Will you need any data members, instance variables in that sorter task? Answer is yes. Which ones? I think that is why I prepared you yesterday for the range and all. DOB. DOB will be the data member. Wrong. Completely wrong. Date. Why date? I have got a student details in the map and I want to sort it as per the date. So you don't require this thing date. What date you are talking about? It will be just the hash map. You have to see main thread is giving you the hash map. Where are you going to require this hash map? In the run method. So of course you'll have to store it in the instance variable and the name of the file, because then you will have those print writers. All this IO part. So I don't know where that date came from. Totally not clear. So all you will have is hash map of students and the name of the file. Okay. So naturally, if you have instance variables, which is the best place to initialize the instance variables? Parameterized constructor. So you can imagine we will write a parameterized constructor. And whether you implement or extend, what does contain your business logic? The business logic is always held into run method. So we'll started thread over, try catch, etc. And I've given you the basic steps, but we will nicely separate it into collection utils, IO utils, everything. Here I'm just giving you what is to be done. So you have a hash map. Okay, sorry. You can do it in an imperative style manner also, as well as functional style. So here I'm just discussing it as a functional. And one more thing I'm going to change here, because see, some things I have already shown you, so repeating those things is like boring. So remove this. I've already shown you in the earlier one, this thing, collect operation, where the stream is collected into the list. So let's go for different things. So here, hash map. Okay, let me ask you. This is nothing to do with the threads. This has everything to do with the collection framework again. Can you attach streams to a map? It's a Boolean question. Yes or no? Is there any stream method in the map? Absolutely not. So you will, but is there a stream method in the collection interface? Yes. So that is the one conversion we will do. Everything can be done in one line, you know that. So hash map, we will convert it into collection of values. Which method to use for this? This is, guys, whole revision of earlier map.values. Excellent. Now I have got collection of student type of references. But the collection doesn't support pipeline of operations. So which is the method to convert it to attach the stream? Stream is the name of the method. So what will this stream method return? Will it return collection or will it return stream? Naturally stream. Stream of primitive types or stream of references? References. Which type of reference, guys? Obvious question. Student type of references. So now I can, so I have got the source operation. Now I can have intermediate final operations, etc. So which is the first intermediate operation we are going to have is sorting. So do you remember any method in the stream interface to use? Which is the method? Filter. Guys, here I have not said any filtering. You cannot blindly apply what you have done. Read the requirement. Here, store the student data sorted as per the DOB. Where that filter answer came from? Wrong. So don't blindly do things. You'll lose the impression. Of course, you have the first and only intermediate operation is sorted. There are two sorted methods. Sorted without arguments, sorted with a comparator. Which one will you go for? See, I'm discussing the whole solution so we can do the parallel programming. Comparator one, because who wants to touch the student class and add something? Natural ordering or custom ordering? It's a custom ordering, of course. And so now if I put a probe here, what is it I have got? I have got stream of, it's an intermediate operation. I have got stream of sorted students as per the DOB. All clear? So if you recall, I don't remember exact which day, but we had also shown you the terminal operation collect. You remember to list, to set, to map or whatever, collectors.toList, and we had collected in the list. So now that thing I have already shown. So let it be an open stream, and that open stream we will give it to the we will give it for writing. So tell me, should we mix up this collection related code and IO related code in the same class, or should we do the separation? Obvious questions I'm asking you. So again, you will have collection utils, IO utils, and those methods earlier main thread was calling. Now the slide changes, your user defined threads will call it. So this writing we will write in the IO util, store data, store student details, something, and we'll finish the thing. Here I had written already constructor. I did not notice that. So I'll just keep quiet for a minute, and you see this will be almost the same. It's like a copy paste, only the sorting criteria changes. So guys, can you visualize this? Can you actually visualize the code so that we can start writing it? Everyone can visualize it. I hope I've given you sufficient practice in the last week of all the things. So only new thing is we are applying the threads. So if you open that sequence, I've shared that sequence also. So always break it down in the steps. So collection utils and all, I'm going to give you ready-made, but I don't think I have written sorting methods. We'll see whatever I have written. So collection utils, populate sample data, etc. Then sorting methods we will add if not written. IO utils, we will have the write data method. So suppose I want to store it in a text data file. Today there are something like 10 students. There can be 10,000. So I want buffering. So anyone wants to tell me what will be the chain of the IO streams you will open in IO utils. So one end is Java application and the other end is your text file. Yes, please fill in the blanks. So here, yes, please. I want a buffering. Anyone? Print writer. Pushkara jo did in between. Yes, Nidhi is right. Why you brought a file output stream? Why you are changing from character to binary? Don't. Keep it all character. It's a text data, right? So the buffered writer is not as cool, as capable as print writer. So print writer does have a buffer. When the buffer becomes full or when you flush or close, let the data be settled into send to file writer, which is a character oriented file writer, and the data from the file writer, it's a node stream, will be written here. Everyone recalls it, everyone understands it. Print writer, file writer, and the text file. Yes. And then we'll be creating the runnable task using the implement scenario. And finally, we'll be writing the tester. And like how I've said in the diagram here, there I said subject tester, we'll have DOB tester, GPA tester, anything you can take. It's just a criteria. So is everyone feeling confident to start the little bit advanced or, the integration of all the things? Okay. So before that, I'd sent you sometime the student collection and all. Anyway, let's not go hunting. Let me send you this. Just a second. Okay, I'll create a zip here and send you all the zip. It's today sometime, sooner or later, you are going to require it. I'll just check whether I have got that com app core student and a subject. Yes. So let me send you, just download the zip so you don't have to waste the basic, time on writing basic classes and all that. And sample data. Basically, the irritating thing is, writing sample data. Yeah. So in the meantime, create a new project 21.1 and in the you will receive the data and I'll give you the instructions. So download extract and you will see there packages. So pick up com and pick up utils. Yeah, I have got that. So pick up com, pick up means control C, this com and utils. Let's create a brand new project for today, first project of today. 100% you can just stay back and observe and try it out on your own in the lab. Absolutely okay. No problem. And like I said, paste the control V. So when you paste it, you got problem here. Oh, parse. I got a parse understand. Collection utils. Okay, I'll have to. Oh, this was an older one, looks like. Give me 2 seconds. This is a loop, but there's some mismatch somewhere. Give me a sec. You can also start looking at it. It's not like you just sit back. Oh, this is an older one. We'll fix it in a minute. It gives you a challenge. So I'm saying I have picked up some code which is looks like an older one. So here, replace date by local date quickly. Start working, guys. Those who are not working can just stay back and understand. So I don't want to go to that look older API. So let's make changes quickly. I might be having somewhere the updated copy. I don't simply remember where. So get rid of this simple date format. make the changes. This is fine. Change it. Yeah, I'll give you the updated one if you don't want. Local date looks okay. And there's nothing like here. I'm just upporting from date to local date. That's it. This is okay. Fine. And here, so there's no no, there's some Wait a second. I'll send you the corrected code. And in local date, so you will not have this at all. And you will simply have Java time dot local date dot parse. Okay. Oh, and yeah, I'll have this also. Why I'm having so many problems? I don't know. Student and the subject. Oh, subjects are different. This was for the some other thing. So let me see which subjects are we talking about. Angular and React and web technology. Okay, let's add that. Separately. Are we good now? Okay. So this looks fine. Okay, so what I'll do is, if you want to take these tiny efforts, go ahead and do that. If you don't want to, let me send you the project zip. There are no problems here. This has just the collection notice. Yeah, good to go. So, (21.1) to archive. I'm sending you the later version so that you don't suffer. You can delete that earlier one and just take this one. On 21st day in Java, you should be able to do all these changes. May not be in such a quick manner because it requires practice, but at least you should be able to understand the changes. So I'll wait here for a minute. You tell me when you have got the when you have done the changes. Very good, Sumit. If you do it on your own, it gives you a different level of confidence. Anyway, you let me know, guys, whenever you have done the changes. Or simply take up that 21.1 zip and continue. So can I continue? Shall we continue? You tell me if anyone wants me to wait. If anyone is in between the changes, let me know. Okay, so nobody's asking me to wait. So now here, read the requirement. We want the student collection. Collection means student map sorted as per DOB and for one thread, and for other thread sorted as per GPA. So I'll give you in writing the comment and you will do it on your own. I'm not added the subject also here. Subject is added, address is not added. Anyway, doesn't matter. Let's not waste time. So is this a class or an interface? It is an interface. Great. So add static method to what? Sort student map. I'll rephrase, sort student details from the map as per what? As per, let's say, GPA. Okay. And return the sorted string. Okay. So this is the question. Let's solve it together. So, it's an interface method. You understand? Okay. Before I ask you, let me be clear. Which thread is going to call this populate map method? Your choices are main, DOB sorter, or this thing, GPA sorter. Who is going to call this? You want me to wait, Rajiv? Okay. GPA sorter is totally wrong. This is populated map. How many times you require populated map? Just once. Did you not see my diagram? Whoever answered me wrong. Here we are going to get that populated map, and that is going to be sent. That is going to be shared with multiple threads. So main is a correct answer. So start writing the method on your own. All you have to do is this. When somebody asks me to wait, Rajiv, I guess, you just take that date 21.zip and extract it. So we don't waste time. So public keyword is already there. Now tell me, what should be the return type of this method? I'm still waiting. A stream. What will be the type of the stream? Student stream. Very right. So here, stream, student. Oh, I'm not control space this. So here, pick up from java.util.stream. Just don't pick it up from anywhere. Again, you'll have incompatibility issues and all. And I'll say sort students. Sort students as per GPA. Something. And what will be the input? I've already given the input, a map. So this can be your, you don't have to say a hash map because later you can change it to tree map, linked hash map, anything. Okay, so just keep it as a higher level map. Waiting here for a minute, write a one-liner code. I have already explained in the diagram. I've already specified all this. This is just a practice of your functional programming, nothing else. I want a one-liner. Okay, so that's your first one, Srinivas. That is your function literal. That is correct. But I want the actual streaming, this actual line here. Okay, let me not waste your time. You cannot attach the stream to the map. So you will have to do the conversion values. This map.values gives you a collection of student type. Then you attach the stream so that you can perform the pipeline of operations. So this is returning you stream. Those who are not typing along, focus totally on understanding. This is your recap of all the things learned so far. Stream. But this is an unsorted stream. So then there is a method sorted. Choose the comparator. Comparator is a functional interface, can be replaced by a lambda expression. So S1, S2. Somebody had suggested me a function literal. You can use a function literal here in lining as you understand. I don't have any problem. So I have a GPA S1 dot get GPA. Oh, sorry. What is it I'm doing? The double the get GPA. And then you have to see this to compare it to another one, S2 dot get GPA. We've done something like this so many times, and this is what you are returning. Are we done? Yes. So let me send you this method for your reference in case you want it. Yes, people have already done it. Some of you have already done it. Yes, Kanad, you're right. And those who finish it, simply write the other method, which will do it as per the date of birth. And keep it also ready. It's just a small change. I'll wait here for a full minute. Catch up. Okay, I'm waiting. It should not take you so much time. Okay, so done. Very good. Try the other method also. I'm not going to waste so much time at all because it is, most of it is the same. Only thing is the criteria changes here. The sorting criteria is date of birth is local date is comparable, so becomes easy. So finish the second one also. Sorted student as per the date of birth. Tell me when both the methods are done. Done both the methods? Okay. And as you know, the sorting criteria is like, don't be changed. So this finishes. So be clear. When you are writing the APIs, you should know which thread is going to call it. So once again, I'll say this populate map is going to be called by the main thread. Who is going to call this method? Main sort DOB thread, sort GPA thread. Who is going to call this method? Easy question. The sort GPA thread. And who is going to call this? The other thread, sort students by DOB. I have just taken two examples. You can add so many threads in addition. Doesn't matter. Okay. So collection utils part is done. Now let us write the IO utils, which will take this stream of data. Are you understanding what is going to be the input for our IO utils? Earlier it used to be list or map or whatever. Now I have got that open stream. So I will have the stream. You know so many operations on stream. So we will write those records for each basically into the file, accordingly. So let us create a IO utils. This IO utils exists already, but this is not of use. So remove this because this works on, actually, why don't you delete the whole thing? Because we want to work on the stream, not on the list. So delete that IO utils and write it on our own. It just takes you 5 minutes at the most. So utils interface IO utils. In separate earlier topics, I've already given you enough practice of it. We are just integrating it with the threads. That's it, nothing more. So add a static method. Don't start writing any implementation without a comment. What is to be done? Add a static method to store stream students in the text file using buffer. Okay, so public keyword is already there. Data writing methods are typically void, and I can say store student details. I have a small question. How many store student details method we will require? One method or two methods? As in one for GPA based sorting, one for DOB based. So one or two. Only one method. Everyone understands that. All I have got is a stream. I don't care. I mean, this method doesn't care how the sorting criteria is. So first is, okay, you tell me, what will be the inputs here? Input to the method. Map and a map and a file name. Gaurav, off track. Stream and a file name. We have already converted the map into a sorted stream. You forgot that. So it will be stream. And stream of students, let's say students something, and of course in which file to save. So somebody told me correctly the name of the file. Okay, and here write it. So when I say write it, first attach the data streams. So you have a Java application, writing it to the buffer of a print writer. When the buffer is full or when you say flush or close, the data will be sent to the file writer as a node stream, which will actually manage the device in form of a text file. Okay, correct. So now open the try with resources. And here you're going to write this one. I mean, you're just going to create the data stream. So print writer new print writer, new file writer, and that has the name of the file. Reach your understanding wise? If you take the cursor here, you will see unhandled exception of the type IO exception, delegate. You can handle it also, but we are anyway going to have the try catch all or something in your thread. So delegating. And now give me that one liner. What should I write after that? I want to take record by record, I mean element by element from that stream and put it on the print writer. So give me the code, one liner code here. We have written something similar. Only thing is that time I think we were operating on list or some other collection. Here you are working on a stream. You just think it over. I'll just be back here. So tell me. Yeah, I got the answer already. Very good. So here, what is students? A stream. So here, start with the students. Do I require any intermediate operation for sorting and all? Already done in that collection utils. So you can now you can close that stream, the terminal operation for each. And here, for each is what? Consumer. You can use lambda, you can use method reference, anything. So print writer, method reference I'm using. If you don't want, you can use a lambda. And on the print writer, on the this thing, print writers, println method you're calling on the everything. So here, if you don't understand this, you can always write the lambda. So for every student record, pw.println s. Whatever you understand is good enough for me. Got it? We have done something similar, but maybe the data type was something else, but it doesn't matter. The operations are the same. So after this terminal operation, stream is now closed. So shall I send this modified file, a modified project? I'll send, so that those who are anyone is lagging behind, I want them to write the threads with me, because threads is the today's main topic, not the collection or IO. So let me again create a zip. And send you away in case you need it. Okay, so I've sent you the code which has what all things we have. We have got those core classes. Student has a subject is a enum. And here you got IO utils and we got the collection utils ready. So you tell me now, what is the next step? What should we do next? Create runnable tasks. Threads we will not create directly. No, tester is the last thing generally we do. Point of integration. So that we will do the develop the last. First, let us create the runnable tasks and keep it ready. So how many runnable tasks are we going to create? One or two? Two. One will be the DOB sorter. One will be GPA sorter. Okay, so you can say Control Shift W and create. See, packages are for separation, segregation. So let us create another package here, src, and create a class. And see, after at the whole idea is, even if you look at our code after 20 days or 2 months or whatever, you should still understand. So the moment you say runnable tasks, I hope everyone will understand. So let's say GPA sorter first. Anything, I mean, it's good. The second one is just going to be copy. And which is the interface you're going to implement? Everyone knows runnable. So implement runnable interface. So at least that run method, basic run method will be given. So here you use your GPS sorted task, which implements runnable. Are we all good so far? Not feeling lost or confused? Okay. Again, majority doesn't respond, unfortunately. Only few people keep responding. So others who are not coding along is fine, absolutely fine with me. But at least they are all understanding or not. Unless until you talk to me, I can't help you. So I hope you are there. So okay, we'll come to the run method later. Here, let's identify the data members, or I can say instance variables or state, whatever. So let me ask, don't just blindly do things because I am doing it. Here, this GPS sorter task is soon going to be attached to the thread. And so that creation of the thread and attaching the task, we will do from the main method as in main thread. And main thread is going to pass. That's why drawing a diagram is so important. What is the main thread going to pass to these individual tasks or threads is the data, hash map of students and the name of the file. So once you are clear on that, you should understand, you should identify that those details such as file name and that hash map, I'm going to require in my run method. But I can't create an argumented run method. Overriding form of a method doesn't allow me to change the signature. So that is why you declare private state, which will be the data members which you want to initialize, file name and the map. So do it logically, understanding wise, and then you can practice. So here I'm saying name of the file. Anything, see, I'm not exposing user to this task. User is going to just talk to your main thread that way. And then I can have a map of students. What was that? I forgot the type. I think it's a integer or this. I'm just checking. Student map type string it is. It's an email ID something. So it is a string comma student. Okay. And here I can have the some variable name. Control Shift O to fix the imports. So all this is fine. Now you generate a constructor, parameterized constructor to initialize the state. Generate it, don't waste time in writing it out. Okay. Oh, it got created below. Let's arrange it properly. Okay. And finally, the main thing is, so now, okay, before I say main thing and all that, now my main thread has passed all this to the thread. So I have an interesting question for you. I'm asking you what will be the output. So what will be the output here? I'm not giving you options here. It's an interesting question that shows me your understanding. What will be the output, guys, here? You understood? Pause your coding. If you are in the middle of coding, pause your typing and answer me. Those who are not coding, that is a majority, they should answer immediately. So Srinivas is saying main. Some of you are saying main. So your choices are main, or what is that? GPS sorter or the DOV sorter. It's a trick question. Guys, who is going to call this constructor? Main thread is going to call this constructor. So you, because that is why the diagram. Main is going to call this constructor, and whatever you do after that in the run method will be passed on the separate thread. 100% a trick question, and most of the time people, fall for that trick. So those who are saying main, very good, excellent. And you'll confirm in a minute or whatever when we write it. This is still under the mains control. The separation or that parallel flow of control code will get executed from run. Okay, so now it's always good to think out of box. So finish that standard template. Which thread started? So I can copy this. You can say import static anytime you want. And thread over. Answer the next question. Now, which name you are going to get? When I say this particular thread got started, main GPS sorter or DOB sorter? GPS sorter. Are we all good? Are we understanding? So this will be, of course, your GPA sorter thread. This is where you get the parallel control. This is still under the sequential access. Mean is going to call it while creating the task and attaching it to the thread that way. And then you can add the whole thing under, that's all and all that. In case there are some, we are delegating some exceptions. Oh, sorry. Don't use print address. Give a better error message, better error handling. So I want to say which thread. So this thread, this is all template, got error and which error, so that our debugging becomes easy in a multi-threaded environment. So this is all the boilerplate code. Boilerplate as a repetitive code, same code. Understood it so far? Clear? Okay. So now the final thing. So what is it? So now understand what your thread has. Your thread has got the data and the file name also. So anyone wants to tell me what should my GPS sorted thread do here? What should I do here in the comment? Call the sort method. Very right. So here invoke, or I'll say this, sort student details as per, this is what, GPA, as per GPA. So do you have to write the sorting code, or we already have that sorted code written? We already have that. So just import static utils, collection utils, and which method we will require for this thread? Populate map, sort students GPA wise, DOB wise, or sort student GPA wise. First, second, or third? Answer is third. You be clear which thread is going to use which utilities, and you just call that. So I'm calling this, sort this thing and passing the map. Okay. So now, so here you can say control 1, and here this is what is the stream. Okay. Now, which is the next operation we want to perform? So I have got this sorted students, sorted stream of students. What else? What is it? Where I want to store it? In a file. So what should I do next? What should I do next? I didn't understand your SCR. Call the method we have already written the IO. So I don't know what that ACR was. Serialization, if you're thinking, you're wrong. We are talking about text data here. So simply invoke store data or whatever to write information in a text file. So what is that method name? I forgot. Store data itself, I guess. Let's check. Store student details. Okay. So here I'll just simply say store. I did not get it because I did not import static thread. Let's do that. Import static utils, IO utils, and the store student details. Guys, you have done all of this and much more, but in a single threaded system. Today I'm just showing you in a multi-threaded manner. So these are the same concepts. So I've got a sorted stream and I've got a file name. And if there are no complications and all, we can give a message. So I can give a message here, student details stored by which thread, and you know how to find out the name of the current thread. Okay, so one is that collection part. So I have not given too many big data operations. I've just given sorted. You can always say, I want to find out a topper of a particular subject. You can do so many things, or first two toppers or whatever. So you can expand on the requirements. Here I just kept it as a sorted students and write it down. Tell me if you're done. Whenever you are done. And if you want to optimize this code further, can I combine these two statements in one line? Of course, yes. So you can say sorted student details, call this method sort student GPA mapwise and do that. But for clarity, for beginners, for freshers, let me do it in 2 steps. I'll repeat what I said. You can easily combine these two into a single operation. But right now this is fine. So I think we are done here. Just check it from the top. We've got a task which has yet to be attached to the thread that we will do in the main. We have these two details are going to be passed from the main thread to our child thread. So declaring the members. This constructor will be called by 100% main thread. You will confirm it in a minute. And once you say, and of course we will be calling start and all from main thread. So once your main thread calls t1.start, then a parallel flow of control will be created. And whenever the sorter thread gets a chance, it will start executing the run method. Are we clear about the threads part of it? Can you visualize the concurrency? Can you visualize the separate threads? Okay, so now it's a 5 minutes, 2 minutes job. I don't want only GPA sorter. I want to show you a parallel operation. Since 90% is going to be the same, please don't waste your time. Copy GPA sorter into, what is that? DOB sorter. And you will tell me change or no change types. So make a copy from GPA sorter task to DOB sorter and start responding. Tell me, data members, change or no change? Zero change. Any change in the constructor? No. So can you tell me the line number which will change? It's better that way. Just tell me a small line number 29. Yes, you are right. So LHS or RHS, the change is limited to what? Only RHS. Are you getting that? Only the sorting criteria change. So let's fix your import statics here. So I don't want sort students by GPA. I want it by DOB, correct? And make the change. That's why I told you to make a copy. Oh, something wrong. Maybe capital, yeah. Okay. And tell me, is this writing part going to be the same? See, we have written such a simple but effective APIs. So I don't have to change the IO utils part at all. It will just take any stream, whether it is sorted by marks or grades or whatever, how does it care? And the file name. And student details are stored by this. So finish it. And the only thing now we have to write is point of integration, which is UI part, which is the main thread. Are all the layers. Are you understanding? Such a layered application we have developed towards the end of your core Java. You have the tester is missing, but you have got threads, you got collection utils, you got IO utils, and the core classes and the stuff. So the only required thing is, only remaining thing is writing the tester of all that. So let's create a SRC package, different package. This is what I call it, not I. This is what we call it professionally as the layered application. Functionally separated layers in separate packages, separate classes. Okay, so let's have a tester here. Test collection IO with threads. It's a multi-threaded application. When you read this name of the file, you will know immediately what we are attempting. So you will start telling me, what should I do first? All these days I was telling you that this is to be done, and then you are writing the code. This time it is reversal, role reversal. What should I do first in the main method, main thread? Main thread is going to call this main method. So let me see. Try with resources. Okay, fine. So open that, because scanner, we are going to take the file names from user. Or you can, this is your main, so you can simply say print status. Done. Next one, what should I do here? Populate map. Yes. So here, populate map. When you actually, guys, you are building that library management system. In that you can introduce threads. So one thread does one particular job, other thread does particular job, etc. So the point is, currently I'm just taking a populated map. If you have end-to-end application like you are building library management system, then you will be taking it from the file, that serial as binary file or some such thing. So here, populate map from sample data. So n number of options you can go as deep, as advanced as you want. Import static, utils, collection utils, and which is the method I should import static, which is the method your main thread is going to require? First, second, or third? Only the first one. Correct. So we got all that collection utils database in that class. You interface. You choose smartly. So you got a populate map. Control 1. Assign the statement to new local variable. I'm just trying to reduce your typing. So populated data done. So my main thread has got a data. Now next thing, you tell me. Yeah, prompt for the file names. So accept the file names. So SOP, file name. So you can have, now this is, people are still confused between sc.next and sc.next line. It is not worth confusing at all. If you decide that user may give the file names with the white spaces, use sc.next line, as easy as that. So enter the first file name. File name, I'll say this properly, to store to store the GPA sorted, anything, GPA sorted details. So guys, don't get confused over small things like this. File name 1. And if I say that user might give me some path which has white spaces and all, don't use sc.next, as use sc.next line. But if you are sure that it is going to be in the same, no white spaces, do it this way. So I seriously don't want you to waste time on such things. And as I was explaining to somebody yesterday, this is almost getting over. Core Java is getting over. Later in advanced Java, you will have the HTTP request coming from the client, and you will not have any scanner and UI at all. We are writing a backend application, server-side application. So all those hassles will go away. So this is your next one. DOB, sorted details, file name 2. Okay. So all done. So I've written the this thing. I've accepted both the file names. Now, next thing, what should I do? Yes. So create the tasks. Okay. Pass whatever information you want to pass to that. Create the task. Attach the threads to the tasks. That's why yesterday I gave you a very simple assignment, even printer, odd printer, but the flow wise it is the same. Attach the threads to the task and without fail start the same. Otherwise nothing will happen. You'll have a single threaded application again. So let's do it in one line. I've given you the practice. I hope I've given you sufficient practice. So let's say thread T1. Which constructor you are going to use? Runnable based constructor. So new thread. the first argument, pause your coding if you are in the middle of it. Otherwise, you may not understand. So this is what I'm going to use, runnable target. So first, suppose I want to use the GPS sorter. So I have got a GPS sorter task. What does GPS sorter task requires? The file name. So which is the corresponding file for that? File name 1, I guess. But the data is that shared data, hash map of the data. And the second one I want to set is the name of the file. I'm so sorry, the name of the thread. So let me call it as GPS sorter, something. So are you understanding? I'm just combining a couple of things. If it is confusing you, you write it in separate lines. As in, you create the task instance first and pass that task to the thread. So I'll repeat, I'll write here, which is the constructor we are using is runnable task and the name of the thread. Okay. Are we all good? Are we all understanding this? Clear? Great. Then the same thing. So here I'm creating another thread T2 and then we will let it run. So new thread. Here the thread class instances are getting created. And so the runnable task is going to be new. This is DOB sorter task. The file name is file2, map is the same. And the name of it is, let's say, DOB sorter. Okay. So your two threads are created, but they are in the newly created state. They have not yet started. So the next thing is obviously, what's the next thing? Start these threads. So T1.start. And it is perfectly all right because they are just created new. So no illegal thread state exception, nothing. Oh, T2.start. And then you don't know how long the individual threads are going to take. So add some SOP main. Orphan condition, no orphan. Waiting for child threads. Finish the execution. Correct? And you know the API T1.join, T2.join. And here, after that, you can give a SOP threads over. Or okay, I can directly say here main over. You have finished that. You will anyway see those threads completion and all that. And we are doing the main over. I'll again wait here for a minute. Yes, main over, Avinash, right. So that we have followed all the rules, standard good rules of multi-threaded programming. And we are just going to check whether we get the desired output. Clear? All these classes, I know earlier it used to be a little scary, but now over the time, I hope you are managing writing multiple classes and connecting them and integrating them. So let me run this first. Wait for a minute, because if you make the mistakes in giving the inputs, everything unnecessary will fail. Okay, so here, so enter the file name. So let's say GPA based. So I'll say GPA.text, something. Here, when you say next line, you are reading the whole data. I'm not given any white spaces. I do not want to. But if you even give the white space, it should work. Don't focus on next and next line. You've got better things to focus on that. And here, suppose I say dob.text. I'm telling you what is expected. I'm also checking. So now see this. Do you remember we had put a SOP? So who is calling those runnable task constructor? Main. The main is still in charge. Then here, main is waiting, join for the children threads to finish execution. This is where the threads have started the execution. This is where the all those things, sorting, the storing and all is done. So DOB sorter that did its job. GPS sorter thread got its job, done its job. And when both the threads are over, main is over. And when all the non-daemon threads are over, application terminates. And as you can see, I have put it in the same folder, same this. Some of you are having problems with the folder rights, permissions and all that. So that you'll have to fix it on your own. So if I say refresh, I'm just checking before this. So this was a DOB based one. So 17, 12, 19, 96, 96, 97, this 9707, 98, 99. Yeah, looks okay. And let's look at that other one also, GPA based sorting. 19, 47, 5, 59, 81. Yeah, so there are no bugs, at least in my code, whatever written. Please try it out and tell me whether you got it, whether you got a correct output. Working fine, great, Prashant. So let me share the completed example with everyone. So you know, if you want to practice it in the lab, now you know how we have done it. So don't refer to the code which I have written. Just read that objective, follow the diagram and try to write it on your own. Or you can change the requirement anytime you want. And that will definitely give you the confidence for trying it from scratch without my help, without any help. This is the final version of the project. Okay. So this completes the level 1 in threads, where you have got, I can say level 2 or whatever, where you have understood hopefully the thread state transition diagram. You have got the feel of creating the threads in different manner. You have understood hopefully the overriding or that implementation of run method. And today you could nicely connect it to your earlier learned concepts such as collection and IO. Are you getting the feel of understanding or lost? What is that vibe you are getting? What is that feel you are getting? Reaching something or lost? Or somewhere in between? It could be somewhere in between. I totally get it. It's a lot of things put together. So take your time. Use second half of today and Sunday in revising the things, starting from functional programming, collections, IO and all, and finally reach the threads. Okay, getting a little bit requires practice. These are the honest feedbacks, Abhijit and Kunal. I cannot expect, I'm not even expecting, I'll be a fool if I expect that I say something and immediately it reaches you. Impossible. So guys, you need a lot of practice. Yes, requires revision, totally. But at least my job is to give you the inputs and your job is to practice sufficiently. So this completes one level in threads. And now I'm just thinking whether to take a break here before going to level 2. It will be logical. Okay, so let's take a break a little early, guys, because yeah, yes, all those statements, right? This one, Kanada, I agree with you here. So now, so you have seen the concurrency. Okay, so concurrent working, concurrent behavior and all that. But we have yet to see we went for this. We went for that, okay, multiple threads gives you a better throughput, better efficiency, better using of resources. All that is fine, great, understood. But when you when you convert your single thread application to multi-thread application, are you going to come across new problems? Are you going to run into new problems? Answer is 100% yes. So I'll just tell you the scenario, and that scenario, as always, after your break, we will see the problem. Every time you have to see the problem, understand the root cause, and then I will discuss the solution. So here is the story. Here is the situation. You have got a joint account. Everyone knows the meaning of the word joint account. Joint account will have how many account owners? One or multiple? Multiple owners. Everyone gets it. So you have got a joint account between two friends or spouse, husband, wife, or whatever I mean. So you got a joint account, and wait, Abhijit, I'm not talked about it. Wait for this, you're too hyper. So here, so once you have a joint account joint account has facilities to withdraw, to what is it called? To deposit funds, to withdraw funds, to transfer funds, and also to check the funds. Everyone with me still? So here, once you have a joint account, suppose there are two users who are, who are using that joint accounts. Think of two users as threads. Okay. When I say two, you can have 20 users operating on the same joint account. So I'm just reducing it to two. So tell me, while one user is depositing the funds, modifying the balance, modifying the state of your joint account, if at the same time concurrently your balance checker, the other user wants to check the balance, if the other thread representing the concurrent user, concurrent transaction, basically we are talking about concurrent transactions here, what will happen? Will he get the correct balance or wrong balance? Incorrect balance. Are you understanding it? So while one thread representing one customer, representing one user is updating the balance, should you allow the second thread to check the balance, or should the second thread be blocked? Of course, the second thread has to wait, second thread has to block. And that is nothing but, guys, writing thread safe APIs. So you have got a shared resource. What is the shared resource, guys? We have that joint account. Okay, so here joint account is the shared resource, and that will be shared between two threads. Two threads means two customers. So one is, let us say, updating the balance. One is, let us say, checking the balance. So initially we will not apply any locks. This is nothing but locking. Locking is equal to synchronization is equal to applying thread safety, which will get it completely. It's a very important concept even for your advanced Java. So we will have to lock. If one user is checking the balance, should we allow the other thread, other user to update the balance? Of course not. And vice versa, when one is updating, the other one should be blocked. Other one should be locked. Okay, so that is what first we will not add any locking, any blocking, and we'll see whether the code is working. Of course, you will see failures. And then we'll sit back and you will understand that, I don't know whether you know this word. Do you know what the word from your OS concept, race condition? You know the term? Everyone knows the term. So race is a competition. It is a competition. So will you have any time racing condition in a single threaded system? Of course not. There's only one one player, one single thread. Of course not. So till today, we never got across this issue. But the moment you convert your application into a multi-threaded scenario, one is, let us say, updating the balance, one user updating the balance, other thread representing other user checking the balance. So what is this race? This race is between whom? The checker thread and updater thread. And if you don't guard your resources, both threads will be able to access the common shared resource concurrently, creating the problem. So after the break, first we will observe the problem. And I'm telling you guys, incorrect data, what is it called? Corrupted data and wrong result, inconsistent result. And then you will identify that you will have to guard the resource. You'll have to log the resource. So please don't be under the wrong impression that you can control the operating system. But you can definitely you can definitely lock your resource, and that locking is done with one keyword in Java. Why Java is so popular in multi-threaded concurrent applications? Because Java makes multi-threading experience easy. That keyword you are going to learn is synchronized. And once you apply this synchronized keyword, there is something called as synchronized methods, synchronized blocks, etc. You will see the problem disappeared with just one keyword. But we of course understand the internals. So we'll draw the proper pictures, I'll show you, share the diagrams and all that, and you will understand the working of internal working of synchronization. And the concept of synchronization, which is nothing but locking is equal to applying thread safety, you will require even in advanced Java, because at that time we will be writing a server-side web application. And you tell me from your web technologies experience, do you ever write server-side web application for one client or multiple clients? Of course, multiple clients. You want to keep it scalable and all that. So multiple clients will be represented by what? Multiple threads. And those multiple threads will be accessing your shared server-side resources. So once again, you will have to think about thread safety synchronization. So that is what we are going to do. We'll start in simple manners, of course, small this. Yes, I'm coming to that, Ragini. So we will start in simple manner, and then we'll write more and more advanced examples. So you have done DBT also, database training is done, database technologies. So tell me, does database allow you something like concurrent read operations, transactions basically? That is what Ragini told me. What are the ACID? What does ACID is an acronym? So what does it stand for? E of ACID, what does it stand for? Atomicity. So when you don't apply the locks, either the code update balance and check balance is not going to run as a single atomic instruction. So any thread can come and spoil the code. So nothing but what we are going to achieve by applying that synchronized keyword or whatever keywords is the atomicity, mutually exclusion. So when one user is updating, second user will have to wait. And that is when you will understand a new blocking condition, blocked on a monitor, which is nothing but a thread which is unable to acquire the lock. So all of these interesting things and its application after 1 hour break. So we will resume at 11:05. So please come in time so you don't miss out on anything. That will be all. See you in hour.